All right, from here on out, we're going to start looking at different crystallographic features. And what I mean by that is we're maybe looking at certain points in a crystal. We may be looking at directions. We may be looking at planes in the structure. So they're just features within a crystal. So let's start with points. So we just want to be able to quantify a particular point in a lattice so that we can describe it to others in a easy, quick form. And so we want to talk about point coordinates. So this specifies a specific lattice position in the unit cell. So if you're familiar with Cartesian coordinates, x, y, z, then this is going to be very similar to that. So the point coordinates are basically fractional amounts of that edge length that we talk about in each of the directions. So we have lattice parameters A, B, and C, correct? Right? So they're going to be the fractional amounts of those lengths that we have. And so the other important thing to mention here is that when we do these crystallographic points, we don't have to specify that this is FCC or this is tetragonal. We can do this in the most basic unit cell, and it applies to any unit cell. It doesn't have to just refer to cubic or any of those. So the example we have here from the book is a point P within the unit cell. So the way that we look at point P is by the fraction Q in the direction of the edge length A. So that's along along the x-axis. So Q is the amount, the fraction of A. And then we have a fractional amount along the y-axis, which is B. The edge length is B. And then the fractional amount along the c-axis, or the z-axis, where C is the edge length. So we have fractional amounts Q, R, and S, which define this point. And so it's written, if we want to kind of label point P, we call it QRS. And in crystallography, unlike maybe Cartesian coordinates, which you've seen before, we don't use commas. So we just say QRS and we don't put commas in between them. So this is the notation that we use for points, for point coordinates. And so again, the notation doesn't imply a specific crystal system. So this is basically, you can think of this as the triclinic because it's the most basic structure, but it would work for any other system. All right, so I want to kind of show you how we would do this for a given point, right? So how we find the point coordinates for a given position. So for example, the body-centered position. Let's say we want to label that the body, instead of calling it body-centered, we want to have an actual point coordinates for it. So what we do is, we can kind of excuse me, think of this as starting at the origin 0, 0, 0 of this coordinate system. So the back left corner of the unit cell, and we're gonna basically find the fractional amounts along each of the lengths. So this is right in the center of the cube, and therefore it's going to be in the x direction, it's going to be half of the length A. So the fractional amount there is 1/2 A. And then again, since it's in the center, that's halfway along this direction, which is B. So it's 1/2 B. And then it's halfway along the vertical direction in the unit cell, which is z-axis, which is the length is C. So the first part, we have the fractional length of A is 1/2, fractional length of B is 1/2, and then the fractional length of C is 1/2. So when we write it, we don't write A, B, and C. We just write the fractional amounts. So we call this 1/2, 1/2, 1/2. And that's how we would describe the body-centered position in any unit cell.